Hi everyone, and welcome to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a fascinating post from Google Research titled Zero-Shot Mono-to-Binaural Speech Synthesis, published January 16, 2025. This article introduces a new neural network method called Zero-BAS that can create 3D binaural audio from a single mono audio source and positional data. What's really cool is this method works without any training on binaural audio, which is a significant advancement in the field. This figure illustrates the Zero-BAS architecture, so we start with a mono waveform. Using the speaker and listener positions, the audio goes through geometric time warping, then amplitude scaling. Alright, next, each resulting channel is processed by a denoising vocoder, using log-mel spectrograms as conditioning, and, well, this ultimately produces the final binaural waveforms. This figure shows the MUSHRA scores, a subjective measure of audio quality. The ground truth GT has the highest score, as expected. Interestingly, Zero-BAS, along with other models like WarpNet, BinauralGrad, and NFS, achieve scores in the 60 to 70 range. Okay, so this indicates that despite being a zero-shot approach, Zero-BAS produces binaural audio comparable to existing supervised learning methods. This figure presents the mean opinion score, or MOS, results on the binaural speech dataset. Okay, so these scores, gathered from human evaluations, measure the perceived naturalness of the generated audio. Interestingly, Zero-BAS achieves a MOS score comparable to the other supervised learning models, and even slightly outperforms WarpNet. As expected, the ground truth has the highest score. So now looking at some objective metrics, this figure compares Zero-BAS against other models and a DSP baseline using metrics like wave L2, amplitude L2, phase L2, and MRSTFT. Okay, well, while Zero-BAS doesn't outperform the supervised learning methods, it performs significantly better than the DSP baseline, and approaches the performance of the supervised methods, which is pretty impressive for a zero-shot approach. So this figure shows MUSHRA scores on a different dataset, the TUT mono-to-binaural dataset. Again, the ground truth scores highest. But look at this. Zero-BAS achieves a score around 80, significantly outperforming the other supervised learning models on this dataset. This suggests that Zero-BAS generalizes better to unseen acoustic conditions. This figure shows the mean opinion score, or MOS, on the TUT mono-to-binaural dataset. So similar to the previous MOS figure, these scores reflect the perceived naturalness as rated by human listeners. Now, what's interesting here is that Zero-BAS achieves a score close to 4, significantly higher than the other models, BinauralGrad, WarpNet, and NFS, which score between 3 and 4. Again, the ground truth has the highest score, as expected. This figure presents objective metrics on the TUT mono-to-binaural dataset. So we're looking at wave L2, amplitude L2, phase L2, and MRSTFT. While Zero-BAS doesn't always achieve the lowest scores across these metrics, it performs comparably to the supervised methods, especially in phase L2. And importantly, WarpNet shows a significantly higher MRSTFT value, suggesting, well, greater deviation from the reference waveform. And finally, to wrap up this post from Google Research on Zero-BAS, this zero-shot approach to binaural audio synthesis is really quite impressive. Key takeaways? Well, it performs comparably to supervised learning methods, without needing any binaural training data, and even generalizes better to unseen acoustic conditions. Okay, so that's all for this week's AI Research Roundup. Thanks for listening.